Hello my dear friends, welcome back to our channel P. Vaishali's Mathematics Classes. I am P. Vaishali. Here we are learning a chapter from the 9th standard, that is a number system. In earlier video we have solved till the question number 5 from exercise 1.3. Now we are going to continue the remaining questions in this video. Look at several examples of rational numbers in the form P by Q. Q is not equals to 0, where P and Q are the integers with no common factors other than 1. Here we have to take such numbers. There should not be any common factor other than 1. And having the terminating decimal representation or the expansion. Which numbers we have to take? We have to take the terminating numbers. And can you guess what property Q must satisfy? Means this denominator, what the property it must have, so that we can get the P by Q form as the terminating decimal representation. Let's see. P by Q, where Q is not equals to 0. Here P comma Q are the integers and there should not be any common factor other than 1. Let us take 9 by 2. What is the decimal expansion of this? After doing the division, we can get 4.5 as the decimal expansion of this 9 by 2. Next, 7 divided by 5. 5 ones are 5. 5 ones are 5. 2 will be remain. 0.054 is 20. The answer is 1.4. Next, take another example. 83 divided by 100. So the decimal expansion is 0.83. All these are the terminating decimal expansions. Then what the Q must have the property, that is asked. So if we observe these three examples, if it is the power of the 2, power of 2, or it can be the power of the 5, or the power of the both. Finally, we can write in terms of 2 power A into 5 power B. Means if it is the power of the 2 or the power of the 5, or if the powers of the both, like this. Here it contains, this 100 contains the powers of the 2 as well as the powers of the 5. So that we can get the terminating numbers. Let us solve the question number 7. Write 3 numbers whose decimal expansions are non-terminating and non-recurring numbers. We have to write such numbers. There should not be terminate and there should not be the repetition of the numbers. Here, first one, 0.20, 200, 2 000, 2 4 times 0, and so on. It is a non-terminating and non-recurring number. Second one, 3.15, 115, 115, 4 times 1 5, and so on. Next, third number, 7.89, 899, 899, and so on. These three are non-terminating and non-recurring numbers. Let us solve question number 8. Find three different irrational numbers between the rational numbers 5 by 7 and 9 by 7. Here, if we have the decimal expansions of 5 by 7 and 9 by 7, then we can write the irrational numbers between those two numbers, right? So, first of all, try to get the decimal expansions of 5 by 7 and 9 by 11 first. 5 divided by 7. So 0.0, because 5 is the smaller than the 7. So put the point here, can take 0. 7 7s are 49. 1 will be remain. So now we can take 0 here. 7 1s are 7. 3. 7 4s are 28. 2 will be remain. 7 2s are 14. 6 will be remain. 7 8s are 56. 4 will be remain. 7 5s are 35. Then 5 will be remain. Again we will get the same series. So what is the decimal expansion of 5 by 7? We can write this as 0.71428 bar. Next, 9 divided by 11. So the decimal expansion of this can be, let's do the division. 0.0 11 8 88. 2 will be remain. We can take 0 here. 11 1 11. Again 9 will be remain. So 11 8 18. Again the same series will be repeated. 9 divided by 11 can be written as 0.8181, means we can put bar over here. Here we have to write the three decimal expansions between these two numbers. These are the decimal expansions. Now let us write the three different irrational numbers. What are the irrational numbers? The numbers which are non-terminating and non-recurring numbers. Now let us write the numbers between these two. Here 0.714285. From this number to 0.80, till that number we can take. Means here 0.71 is given here. Means we can start it from the 0.72 to 0.80. First irrational number we can write this as 0. Here you can take 72, 73, 74, any number. Let us take 7, 2, then 0, 7, 2, 00, 7, 2, 000, 7, 2, 4 times 0, and so on. This is the first irrational number. Then second one, 0.756, 7566, 7566, and so on. We have written the two. Last one is remain. Third one. So we can take it as till 0.80. Let us take it. 80, 8, 00, 8, 000, 8, 4 times 0, and so on. These three are the irrational numbers between these two rational numbers. Let us solve the last question of this exercise. Classify the following numbers as rational or irrational. What is a rational number? A number which can be written in the form of p by q. And what are the irrational numbers? A numbers which are non-terminating and non-recurring numbers. Second one, the numbers which cannot be written in the form of p by q. And the third one, the numbers in under root which are not the perfect squares. All these will come under the category of the irrational numbers. Now here some questions are given to us. Based on the criteria of that, we have to decide what type of the numbers they are, whether they are the rational or the irrational numbers. Next, root of 23. As root of 23, it is not the perfect square of the any number. So what type of the number it is? It is irrational number. Given number is irrational. Next, root of 225. It is the square of the 15 only. We can write this as 15 whole square and square root get cancelled. It is 15. Is this number in the form of the p by q? Yes, it is in the form of the p by q form. So we can say that the root of 225 is a rational number. Next, 0.3796. How can we write this number? 0.3796. This can be written as 3796 divided by, can we write 4 times 0 at the denominator after 1? 1, 2, 3, 4. Now, this number we can represent in the form of the p by q. So that's why it is a rational number. Next here, 7.478, 478 and so on. This number is given to us. 7.478 bar because 478 is repeating here. So in earlier questions we have solved, if any numbers are getting repeated, then we have already converted the given numbers into the p by q form. Here we can also convert this number into the p by q. So that's why this is also a rational number. Next here, 1.10, 100, 100, 1, 4 times 0, 1 and so on. Means the number is not going to repeat. Means there are no repetitions. It is non-terminating and non-recurring. Next, what type of the number is this? It is a irrational number. In this way, we can determine the numbers according to the rational and irrational. Thank you.